function. So all this is a special case of 2.8. So we'll start with 2.8. I'm going to draw something, and you are going to remind me what this is. We've seen this so many times. We've seen this so many times that you're probably fed up with it. So what did we illustrate with this? We illustrated the yes, that's true, the average rate of change between P and Q, but we also called it difference quotient. Very good. So this was the figure for the difference quotient. And we also said, I know it was a long time ago, but we said that the slope of the secant line PQ will approach when age approaches 0. The slope of the secant line PQ will approach the slope of the tangent line at P. But this we wrote a long time ago when we did not know something very important that we learned in between, in the meantime. So now I'm going to ask you, what is the slope of the tangent line at P equal to? So the slope of the secant line was f of the slope of the PQ, f of x divided by h, and that's a difference quotient, right? But what is the slope of the tangent line now? Okay, let me write it first so you can see it. So I'm going to white this out. Not to confuse you when you look at it, I'm hoping you do. So we said that the difference quotient was f of x plus h minus f of x divided by h. And this is also the slope of the secant line PQ. Now I would like you to give me an expression, something that I could replace the slope of the tangent line at P with.
Limit.
Awesome. Thank you.
The limit of the difference quotient as h approaches 0.
That's it. That's what it is. As we bring Q closer and closer to P, H gets closer and closer to 0. But now we no longer write those arrows. We write the limit operator. So the limit of the difference quotient is the slope of the tangent line at P. This has so many different interpretations. Bless you. Here they are. Number one, this is the function named f prime of x which is the derivative of f of x. Number two, what this represents. So the limit of the difference quotient as h approaches 0 is number one, the function f prime of x, which is the derivative of f of x. Next, f prime of x gives the rate of change of f of x at any x value where, this is another word that we have to explore, where f of x is differentiable. I'll explain what differentiable means. And when we say about a function that is differentiable, under which conditions the function is differentiable. Okay, let's summarize from the beginning. This is not the end, so I have more to say. So the slope of the tangent line at P is the limit as h approaches 0 from f of x plus h minus f of x over h. To be exact, this should be, so to be 100% accurate, this should be when x approaches a. But this is fine. This is for the definition of the function, of the derivative. But in order to be exact, we have a slightly different, very slightly different definition for this particular number, because this is a number and this is a function. Okay. So all this is the function named f prime of x, which is the derivative of f of x. F prime of x gives the rate of change of f of x at any x value where f of x is differentiable. Number 3, f prime of x gives the slope of the tangent line at any x value, same thing, where f of x is what? Yes. So f prime gives the slope of the tangent line at any x value where f of x is differentiable. And one more. Number 4. All these mean the same thing. F prime of x gives the instantaneous velocity if f of x is distance. On the same conditions where the function f of x is differentiable. So from the beginning, this is the function named f prime of x, which is a derivative of f of x. It gives the rate of change of f of x at any x value where f of x is differentiable. And f prime gives the slope of the tangent line at any x value where f of x is differentiable, or if f is the distance, then f prime will give us the instantaneous velocity at any x value where the function is differentiable. I need to explain what a function is when it's not differentiable, and then we'll discuss when it is differentiable. There are 3 situations in which a function will not be differentiable. Like with continuity, jump, infinite, and removable, same thing here, not the same situation, but I'm saying similar in the sense that there are also 3. Here is one. Right. In other words, when the function is not continuous. It could be jump, or it could be infinite discontinuity, or it can be removable. So when f of x is not continuous, so at that point the function is not differentiable. So not differentiable because it's not continuous. Here is a second type. It's going to be the same thing, discontinuous. When a function has a cusp or a corner at this point and this point, the function, although it's continuous, the function is not differentiable. So a function that has a cusp or a corner, like the absolute value. This is the absolute value of x. But move to the right. X minus 5. It's not differentiable at 5 if this is 5 because it has a corner there. Same thing with the cusp. And here's the last one. And I'm going to graph a function that we should always remember. I graph the function the cube root of x. This function is not differentiable at 0 because it has a vertical tangent. Vertical tangent. So not differentiable. It's differentiable everywhere except at 0 because it has a vertical tangent, and a vertical tangent has a slope that is undefined. Here it's not differentiable because on this side the slope of the tangent is positive, and on this side the slope of the tangent is negative. So which one is it? So there is a gap in the graph of f prime. When f prime is not continuous, the function is not differentiable. Yes. The same thing here. This is a negative slope and this is a positive slope. So there is no unique tangent. At this point, I have two tangents. The function has two tangents. It has to have one tangent, not two. And here, of course, it's not differentiable. So, because it's not continuous. So differentiability implies continuity. So if a function, if I'm told a function is differentiable, it must be continuous. And it cannot have any of those. Corners, vertical tangent, cusps, and so on and so forth. However, if a function is continuous, can I conclude that it is differentiable?
No.
No. This is false. So if I'm told the function is differentiable everywhere, it's continuous everywhere. If I'm told that the function is continuous everywhere, I cannot conclude that it's differentiable. As long as it does not have cusps and corners and vertical tangent, then it is. But I have to check that. So, when is a function differentiable then? When it's not discontinuous, it does not have a cusp, it does not have a corner, and it does not have a vertical tangent. So it was easier to explain when a function is not differentiable. In all the other cases, the function is differentiable. Okay, so here's our first question here. And this is on page, if you have your textbooks, we are on page 163. And I would like to look at an example. Let's say problem 29. They say g of t, I'm going to call it f of t. Doesn't matter. 1 minus 2t divided by 3 plus t. We are asked to find f prime of t using the definition. So what is the definition of f prime of t or f prime of x? Let's say f prime of t. What is the definition?
F of t plus h.
Yes, but it's the limit.
Oh, it's the limit.
It's the limit. Yes. So any derivative is the limit of the difference quotient. So the limit as h approaches 0 from the difference quotient. Let's write the difference quotient first, and then we'll put it in. Very good.
minus FT
Very good.
all over H.
Very good. So you understand why section 2.8 is basically we put together what we studied so far, the limit together with the difference quotient. That's all it is. Put those two concepts together. Good, so now dictate. Actually, from this moment on, you do not need my help. So 5 minutes. I'm tired. No, I'm kidding. I'm kidding. I'm kidding. I'm not going anywhere. I'm here watching you like a hawk. Now, we did this portion. For one second, if you'd like to look. We did this portion in the first 2 sections of this chapter. We did this with this in the next 4 sections of this chapter. And now we're putting them together. Let me know if you need any help. You should not. I'm kidding. Can anyone dictate just the first step for everyone to be on the same page? So 1 minus? Yes, I'm going to distribute. Very good. Awesome. And then I copy the function. And then h in the denominator. And what will be the next step? Very good. We have to find the least common denominator. So please work on the least common denominator. Can anyone give us the least common denominator?
3 plus t, or you do the small one. Parentheses 3 plus t, parentheses another factors, 3 plus t plus h.
Perfect. Can anyone give us the adjustment for the top of the first one?
Cross multiply. 3 plus t one side, 3 plus t plus h.
Good. It's a lot of multiplication. Now let me refresh your memory. 2 things must happen every time we simplify the difference quotient. What are those 2 things?
Each on the bottom has to go away.
Yes, but that's the second one. And what is the first one?
The
All terms
well,
from the top that do not have
H.
must go away. If some of them have H and go away, it's a plus. But all terms without H must go away. Otherwise, there is an error somewhere. Can anyone start, or you're not there yet? We need more time? Very good. I'm very pleased to see that no one misses class. I'm very proud of you. Thank you. Yes? You need help?
Why can't we drop the limit?
Why? We cannot.
Do you drop the limit?
Only at the very end.
Okay, so we're right. I'm trying to cancel the H.
However, there must be a denominator. The denominator does not go away. Careful. And the answer must be a function. We are determining f prime. So I want to see a function. F prime is a function. If the function is a rational function, the derivative cannot be a number. So can anyone dictate, please, the top? We distribute 3 to all these 3 terms. So 3 minus 6t minus 6h. We agree with the first 3? So 3 minus 6t minus 6h, correct? Now I distribute t plus t minus 2t squared minus 2th. So far so good? Do we have these 6 terms? Now I'm here with minus. 1 distributed to all these, but I'm really distributing negative 1. Negative 3 minus t minus h. Now I have negative times negative 2t, which is 2t, so I'm distributing 2t, plus 6t plus 2t squared plus 2th. All terms without h must go away. It's a bonus if more than just those. But I'm not expecting anything. So the 3 with a negative 3, the 6t with a negative 6t, the 2t squared with a negative 2t squared, luckily 2th with negative 2th, positive t with negative t, and what is left is this and this. Everything else has canceled out. So I have a negative 6h with a negative h. So I have limit as h approaches 0, negative 7h over 3 plus t, 3 plus t plus h, and I flip 1 over t, 1 over h, and I put it in front. As planned, all terms without h went away, and now when I divided the top by 1 over h, I flipped it into 1 over h. What would happen at this stage? I must, like before, do what? Cancel h, they go away, and only now I replace h by 0. So this approaches 0. The numerator is negative 7. What about the denominator? That's it. One thing, I jumped without asking you, and I apologize for that. We knew the answer, but I should have stopped and asked you. So for example, from this stage, I need to know what type of limit this is. The denominator is definitely 0. This is 0. This is 0. So 1 minus 2t over 3 plus t minus 1 minus 2t over 3 plus t, what is the top? 0. So it's an indeterminate case, 0 over 0. There is hope. Got it? There is hope. And the limit exists. Indeed, it's negative 7 over 3 plus t, everything squared. Now coming back here for a second. The function that we determine the derivative at is this. Where is this function not defined or not continuous if you want? Right. So is its derivative. So it's its derivative. Obviously. If a function is not defined at a point, it cannot be differentiable there. Right? Because it has a gap. It's not continuous. If it's not continuous, it cannot be differentiable. So the function does not exist at negative 3. Of course, the derivative does not exist at negative 3. Okay, I think we should look at one more example like this. Ready? Yes? What about 23? We are given f. I'm going to change it into f of x. It will be easier for you. We're asked to find f prime. 2 minutes. Using the definition. What is the definition of the derivative? Is the limit of the difference quotient when h approaches 0.
Is that 5x?
I'm sorry?
Is that
5x, yes. Sorry. 5x minus 9x squared. 2 minutes. One more time, the derivative is the limit of the difference quotient when h approaches 0. We need to remember this forever. Use another table nearby. So they are very uncomfortable, I agree.
We're so tight. We barely
Yes.
have a notebook.
Yes, sorry about that.
This is school for bats.
Do your other professors, are they as slow as I am in class? 'Cause I feel I'm very slow.
It's slow, but it's helpful. I mean, it's.
Okay.
Yeah.
Okay, I feel that I'm very slow.
It does not exist.
Okay. Okay,
We're doing it positive and negative.
so I'm not going to finish today. And after this one, I would like you to determine the derivative for this function using the definition of the limit, of the definition of the derivative as a function.
You say that.
The derivative is the limit of the difference quotient when h approaches 0. So the derivative is the limit of the difference quotient as h approaches 0. Is that okay? If you need help, let me know, please. We're okay? Can anyone dictate the first step?
Write the difference quotient. So 5x limit as x approaches, sorry, h approaches 0 is 5 times x plus h minus 9 times x plus h plus c squared minus 5x minus plus 9x.
Do we all agree with this first step? F of x plus h minus f of x over h. And the limit must be out there. F prime does not equal this. F prime equals the limit of this. So if you do not write the limit operator, this is not correct. The derivative is the limit of the difference quotient. Perfect. So now, yes, whenever we calculate the limit of the difference quotient, two things have to happen. What are they? All terms without h from the top, they have to cancel out. And eventually, at the very end, the h in the denominator has to go away because that is what it creates 0 over 0. But now we know. That's why it goes away. But a month ago, we did not. So 5x plus 5h minus. We have an agreement on this.
Close. 18x minus.
So remember, please, we have an agreement on this, which is x squared plus 2xh plus h squared. And we distribute negative 9. All terms without h must go away, otherwise we know we have an error somewhere. These two go away. These two go away. And there is nothing else. Now I have to have an h coming out. I didn't say it, but of course it's 0 over 0. So we have limit as h approaches 0. The top has h in common. I have to pull it out. That's why all terms without h must go away so that I can pull out an h. That will eventually cancel the denominator. So what is left at the top? A 5. Yes? Very good. Obviously, the problem of 0 over 0 is eliminated right now here because h approaches 0, 0 over 0. And then the final simplified form is, yes, negative 18x plus 5. And this is the function that gives the rate of change of the original function at any point x. Why at any point x? Because this is a polynomial. The polynomial is differentiable everywhere. It will have a derivative everywhere. It will have a tangent everywhere. It will have a slope of the tangent everywhere. Okay, last one and we'll stop. I want you to determine this for me. So we have f of x, which is the square root of x. And I need to find f prime of x. And moving forward, you must remember this result, not the other two. You will never remember this. There is no point. But this is a super important result that we have to remember moving forward. Joe, did you determine this already?
It's a difference.
You're looking forward to get your quarter, right?
No.
I'll make it into a 50 cents. If you do this correctly. Say it again. Yeah, Joe made the deal with me. Before we do this, anyone has any questions on the previous derivative? Okay. Can anyone dictate the first step? And then I'll wait for you to finish it.
Yeah, the operator.
Yes,
Yes.
h approaches 0 from,
The difference quotient, which is root x plus h
very good, minus,
minus the root of x
very good, over,
h.
good. From everything we studied up until now, how and what will you do? Of course, it's 0 over 0, 0 over 0. So what will you do? What is the only way? Yes, rationalize the numerator. What will you rationalize the numerator by? Very good. Can anyone dictate the top? And the denominator is what I see. These two go away, as expected. All terms without h must go away. And then we have limit as h approaches 0 from h over the square root of x plus h plus the square root of x. And as expected, the second thing, bless you, the second thing is happening. What is the second thing that is happening? Right, as we know from a month ago. And now, only now, I am ready to apply the limit operator, and it goes away. Which is an apple plus an apple, which is 2 apples. So please remember, the square root of x prime, from now on moving forward, we're not going to go back to this, is what? The derivative of the square root of x is 1 over 2 the square root of x. Thank you.